Class 11 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 2 Algebra. Topic Sequence and Series. Subtopic Geometric Progression GP. First term Common Ratio, General term, Sum to n terms of a GP. Geometric mean GM. Insertion of geometric means between two numbers. Relation between AM and GM. Exercise 9.3. Geometric progression. What is the geometric progression? A sequence A1, A2, A3, A4, An is called a geometric progression if each term is non-zero and A of n plus 1 divided by A of n is equal to R, where R is constant for n greater than or equal to 1. The constant R is called common ratio of the GP. If A is the first term and R is the common ratio of the GP, then the GP is written as AR squared dot dot A of R n minus 1 comma dot dot. General term of a GP. The general term of a GP is denoted by An in the above GP, whose value is A times of R to the power n minus 1. It is the general term. Sum to n terms of a GP, whose sum is denoted by Sn, which is equal to A times of 1 minus R to the power n by 1 minus R, where 1 is greater than R, or Sn equal to A first term times of R to the power n minus 1 divided by R minus 1, where R is greater than 1. We have two formula for sum to n first n terms of a GP. We have to apply the conditions appropriately. Geometric mean GM. If three numbers are in GP, then the middle number is called a geometric mean between the other two numbers. If three numbers are in GP, then the middle number is called a geometric mean between the other two numbers. Thus, if A, capital G, B are in GP, then G is called a GM between the two numbers A and B. Then G is equal to square root of A product AB. 5. Insert n geometric means between two numbers A and B. We have to fill up n geometric means between A and B. Let x1, x2, x3, x4, xn be n geometric means between A and B. Then A, x1, x2, x3, x4, xn, B are in GP. Using its general term, that is An equal to A times of R to the power n minus 1, we get B. An is replaced by B because it is the last term, and in this sequence GP, A is the first term is A exactly, and common ratio is taken as R, and number of terms from A to B is n plus 2. And therefore, we have to put n plus 2 for n minus 1. Solving this, we get A times of R to the power n plus 1, and solving R equal to B by A whole to the power 1 by of n plus 1. The n geometric means are x1, whose value is AR. R is this, and x2 is AR square, whose value is this. X3 is AR square cube, whose value is this. So on xn is A times of B by A whole to the power n by n plus 1. These are the n geometric means between A and B. Relation between AM and geometric mean. Let capital A and capital G be AM and GM between two positive numbers A and B. Then A is the arithmetic mean between A and B. Therefore, capital A equal to A small a plus small b by 2. And G is also a GM between small a and small b. Therefore, capital G is equal to square root of product AB. Now, A minus G, A whose value is here and G whose value is here, we get this. And which is completing perfect square, we get square root of A minus square root of B whole square by 2. Numerator is always 0 or positive. Denominator is always positive. Therefore, whose value is always greater than or equal to 0. This shows that A is greater than Z or A equal to Z, implies A is greater than or equal to Z. This is the relation between AM and ZM of two positive numbers. Exercise 9.3. Question number 1. Find the 20th and nth terms of the GP 5 by 2, 5 by 4, 5 by I, ... For the GPA, first term is 5 by 2, common ratio is second term divided by first term, that is half. Therefore, A20 is AR to the power 20 minus 1. A is 5 by 2, R is half, whose power is 19. We get 5 by 2 power 20, which is the 20 term. And n term is denoted by an, which is equal to AR to the power n minus 1 is n by 2, R is a half, whose power is n minus 1. Simplify, we get 5 by 2 power n. Question 2. Find the 12th term of a GP whose I term is 192 and common ratio is 2. We have to find out 12th term of a GP whose I term is 192 and common ratio is given as 2. For the GPA, I is equal to 192, R is 2. Therefore, A we have A times of R to the power I minus 1 equal to 192. A remains unchanged. R is equal to 2. We get A equal to 3 by 2, which is the first term. Therefore, A12 is A times of R to the power 12 minus 1. A is replaced by 3 by 2, R is replaced by 2, and solve, we get 3 times of 2 power 10. That is 3072, which is the 12th term of the GP. Question number 3. The 5th, 8th, and 11th terms of a GP are small p, small q, small s respectively, so that q square equal to product of ps. Let small a and small r be the first term and common ratio of the GP. Then p is equal to a times of r to the power 5 minus 1, that is a times of r to the power 4. Q is also a r to the power 7. S is also a r to the power 10. Now product of PS, put their respective values. P already equal to a r to the power 4. S is already equal to a times of r to the power 10. Their product gives a square r to the power 14. Taking out 2, we get a r to the power 7 whole square. A r to the power 7 is already equal to q. It is replaced by q. We get q square equal to ps. Hence proof. Question number 4. The fourth term of a GP is square of its second term. The fourth term of a GP is square of its second term, and the first term is minus 3. These are given. Determine its seventh term. We have to find out its seventh term. Let R be the common ratio of the GP. By question, A4 is A2 square and A is given as minus 3. A4 is equal to A times of R to the power 4 minus 1. A2 is equal to AR as it is second term. A is replaced by minus 3, and solving we get R equal to minus 3. Therefore, A7 is A times of R to the power 7 minus 1. A is replaced by minus 3. R is also replaced by minus 3. And solving, we get minus 3 power 7, whose value is minus 2187. This is the seventh term of the GP. Question number 5. Which term of the following sequences 2, 2 root 2, 4, so on is 128? Find the number of terms that is 128. The sequence is a GP with a first term is 2 and common ratio is second term divided by first term, that is root 2. Using an equal to a times of r to the power n minus 1, that is using its general term, we get an is replaced by 120i and a is replaced by 2, r is also replaced by root 2, whose power is n minus 1. Solving n, we get n is 13. Therefore 128 is 13 term. Similarly for b, it is SGP of a equal to root 3 and r is root 3. How does it obtain? Second term is divided by first term, we get root 3. Using its general term, we get an is replaced by 7 to 9, and a is replaced by root 3, r is also replaced by root 3. Solving n, we get 12. Therefore 7 to 9 is 12 term. For C, here a is 1 by 3 and r is second term divided by first term, that is 1 by 3. And its last n term is 1 by of this. Using its general formula, general term, we get this. Replace a n is replaced by this, a is replaced by 1 by 3, r is replaced by 1 by 3, whose power is n minus 1. Their product is 1 by 3 power n. Therefore 3 power n is equal to 3 power 9. It implies n equal to 9. Question number 6. For what values of x the numbers minus 2 by 7, x minus 7 by 2 are in GP? Since minus 2 by 7, x minus 7 by 2 are in GP, therefore second term divided by first term equal to third term divided by second term, and cross multiply, we get x square equal to 1. Solving x equal to plus minus 1. Find the sum to indicated number of terms in each of the geometric progressions in exercise 7 to 10. 7, 0.15, 0.015, 0.0015, 20 terms. The given sequence is a GP of whose first term is 0, a is 0.15, common ratio is second term divided by first term, that is 1 by 10, n is given as 20. Using sum to first n terms of SGP, we get as 20 is a is replaced by 0.115, r is replaced by 1 by 10, and n is replaced by 20. We get this, which is the sum to n sum of the first 20 terms. Number 8. Root over 7, root over 21, 3 times of root over 7 up to n terms. Here a is root over 7, r is second term divided by first term, that is root over 3. Using Sn equal to a times of r to the power n minus 1 by r minus 1, we get Sn equal to root over 7 times of root over 3 whole to the power n minus 1 divided by root over 3 minus 1. After simplification, question number 9. First term is 1 minus a square minus a cube n terms if a does not equal to minus 1. Here a is 1, r is minus a. Therefore Sn equal to this, giving their respective values, that is a is 1, r is minus a. We get this, which is the sum to n terms of the GP. For question number 10, x cube, x power 5, x power 7 n terms if x does not equal to plus minus 1. For this JP, first term a is x cube, common ratio is second term divided by first term, that is x square. Therefore Sn equal to, giving the respective values, we get this. After simplify, we get this, which is the sum to n terms. Question number 11, evaluate this value equal to, we have to put k equal to 1, we get first term, k equal to 2, we get second term, k equal to 3, we get this, k equal to 11, we get last term. How many terms are there? There are 11 terms, bracketed terms, and sum of this is 2 is repeated 11 times. We have its sum is 2 into 11, and combining second terms, we get 3 plus 3 square plus 3 cube plus plus 3 to the power 11. The bracketed sequence is series is in GP, whose sum is, applying proper formula, we get this, and simplify, we get this, which is the sum of the above expression. 12. The sum of first three terms of SGP is 39 by 10 and their product is 1. Find the common ratio and the terms. First three terms, the sum of the first three terms of SGP is given as 39 by 10 and their product is 1. Let A by R, A R be the three consecutive terms of the GP. We have to take in this form. Their sum is given as 39 by 10. Taking A from each term, we get this, which is equation 1. Also, it is given that the product of the first three term is 1. We get A cube equal to 1. Solving A equal to 1. Using this value A in equation 1, we get an equation involving R. And we get a quadratic equation in R factorized. By splitting middle term, we get this. Solving R equal to 5 by 2 or 2 by 5. Therefore, the common ratio is either 5 by 2 or 2 by 5. And number of terms is, and the terms, the three terms are A by R. A by R is 2 by 5, 1 5 by 2 or 5 by 2, 1 2 by 5. 13. How many terms of GP 3 square 3 cube are needed to give the sum 120? We have to find out number of terms whose sum is 120 in this GP. Here A is 3 and R common ratio is 3, Sn is 120. Using the sum Sn equal to A times of R to the power n minus 1 by R minus 1, we get Sn is 120, A is 3, R is 3. Multiply by 2, we get this, and transferring and solving n is 4. Therefore, number of terms is 4. Question number 14. The sum of first three terms of a GP is 16 and the sum of the next three terms is 120i. Determine the first term, the common ratio, and the sum to n terms of the GP. It is given that the sum of the first three terms of a GP is 16 and the sum of the next three terms is 120i. Let A by R, A R be the first three terms of the GP. Then their sum is A by R plus AR equal to 16. Solving, we get this, which is equation 1. And the AR square, AR cube, and AR power 4 be the next three terms of the GP. Their sum is also given as 120i. Taking out AR square, we get this, which is equation 2. Equation 1 divided by equation 2, we get this by this, and the right side also 16 by 120i. Solving R cube equal to I, that is R equal to 2. We have known that R is 2. Equation 1 giving R equal to 2 in the equation 1, we get this, from which we have solved A, the first term, that is 32 by 7. Now we have known first term and common ratio. Therefore, sum to n terms of the GP is, therefore first term is A by R, that is 16 by 17. R is 2 and S and sum to n terms is, using appropriate formula, we get this. 15. Given a GP with A 7 to 9 and 7 term is 64, determines S7. Given a GP with first term is 7 to 9, its 7 term is 64. Determine S7, sum of the first 7 terms. Here A is 7 to 9, A7 is 64. A7 whose value is AR to the power 7 minus 1 equal to 64. A is 7 to 9. Therefore, R is 2 by R power 6 is 2 by 3 power 6. Equating, we get R equal to 2 by 3. Therefore, S7 is A times, so 1 minus R to the power n by 1 minus R. We get this value. Simplify. Lastly, we get 2059, which is the sum of the first 7 terms of the GP. 16. Find a GP for which sum of the first 2 terms is minus 7 and the fifth term is 4 times the third term. Find a GP for which sum of the first 2 terms is minus 4 and the fifth term is 4 times the third term. Let A by R, A R square be the first 5 terms of the GP. Then sum of the first 2 terms is minus 4. Solving we get equation 1. And the fifth term is 4 times of the third term, that is AR. AR cube is equal to 4 times of AR. We get R square equal to 4. Solving R equal to plus minus 2. When R is 2 in equation 1, we get A equal to minus 8 by 3. When R is minus 2 in equation 1, we get A is minus 8. Therefore, the GP is A by R, AR. That is, A is minus 8 by 3 by 2 minus I by 3 minus I by 3 into 2. That is minus 4 by 3 minus I by 3 minus 16 by 3. Or minus 8 by minus 2 minus 8 into minus 2. That is 4 minus 8, 16. So on. 17. If the 4th, 10th and 16th terms of a GP are X, Y and Z respectively, prove that X, Y, Z are in GP. For the GP, A4 is given as X, A10 is given as Y, A16 is given as Z. Therefore, A4 is replaced by AR cube, A10 is given by AR power 9, A16 is given as AR 15. Now, Y by X is R power 6, Z by Y is R power 6. Rights are equal, therefore lefts are equal, which gives X, Y, Z are in GP. Hence proof. Question number 18. Find the sum to n terms of the sequence 8, 8, 8. We have to find out sum to n terms of the given sequence. Sn is 8 plus 8 plus 8 plus nth terms. Taking out 8 from, and again taking out I by 9, we get 9 plus 9 plus 9 plus dot plus n term. And 9 can be written as 10 minus 1, 99 can be written as 100 minus 1, so on. And combined first terms we get this, and the combined second term we get minus n times so 1. Applying GP we get this, and taking out the sum to n terms is this. 19. Find the sum of the products of the corresponding terms of the sequences this. Find the sum of the products of the corresponding terms of the sequences this and this. Sequence. Let S5 equal to 2 into 120i plus 4 into 32 plus 8 into 8 plus 16 into 2 plus 32 into half, whose value is this. This is a GP. Therefore, S5 is, first term is 256, 1 common ratio is half. Cancelling, we get this. Therefore, the S5 is 492. Question number 20. So that the products of the corresponding terms of the sequences this and this form a GP. Firstly, we have to show that product of the corresponding terms of the sequences form a GP. And secondly, we have to find out their common ratio. The resulting sequence is AR square into AR square, so on. Lastly, AR to the power n minus 1 into capital A capital R to the power n minus 1. Clearly, the sequence form a GP with common ratio is second term divided by first term, we get RR. Question number 21. Find 4 numbers forming a geometric progression in which the third term is greater than the first term by 9 and the second term is greater than the fourth by 18. Let A by R, AR square be the 4 numbers in GP. Then AR second term minus A by R first term. We get third term minus First term given as 9. Solving we get this, which is equation 1. Also a second term minus 4 term ar square is given as 18. We get equation 2. Dividing equation 2 by equation 1 we get, and solving r equal to minus 2. Equation 1 gives a is equal to minus 6. Therefore, the four numbers are minus 6 by minus 2, minus 6 into minus 2, minus 6 into minus 2 whole square. That is 3 minus 6, 12 minus 24. To 22. If the p, q, and r terms of a GP are small a, small b, small c respectively, prove that their product is 1. Let x be the first term and y be the common ratio of the GP. Then small a, which is p term of the GP, x times of y to the power p minus 1. B is q term of the GP, which is equal to x times of y to the power q minus 1. C is also r term of the GP. Therefore, c equal to x times of y to the power r minus 1. Now left hand side equal to, giving their respective values, that is a, b, c respective, we get this, and product we get x to the power this, and into y to the power this. Simplify we get y to the power 0, which is 1. Hence proof. 23. If the first and the n term of a GP are small a, small b respectively, and if p is the product of n terms, prove that p square equal to product ab whole to the power n. If the first and n term of a GP are a and b respectively, and small p is the product of n terms, prove that p square equal to product of ab whole to the power n. We have b equal to ar to the power n minus 1 for a GP. Also p is equal to a into ar square into ar to the power n minus 1. Therefore, p becomes a to the power n into r to the power 1 plus 2 plus 3 plus n minus 1. Their sum is, using standard formula, we get this. Now squaring on both sides we get this, and simplify this we get this, which is replaced by what, which can be written as this, which is this factor is represented by b. Hence proof. 24. So that the ratio of the sum of first n terms of a GP to the sum of terms from n plus 1 to twice nth term is 1 by r to the power n. We have Sn equal to this, and capital Sn, first one is small sn equal to this, and capital Sn is equal to this. Their ratio is 1 by r to the power n. 25. If a, b, c, d are in GP, so that product of these two expressions equal to this square. It is given that a, b, c, d are in GP. Therefore, b by a equal to c by b equal to d by c. Each fraction being equal to rc. Then first member give a b by a equal to r gives b equal to ar, and similarly c by b equal to r gives c equal to br. D by c equal to r gives d equal to cr. Now left hand side expression is written, and giving their first factor remains unchanged. Put b equal to ar, b equal to ar, c equal to br, d equal to cr, and whose square is this, and taking out r square we get this, and the right hand side is written, and giving b, a remains unchanged, b equal to ar, c equal to br, d equal to cr. Taking out r we get this. These two right hand sides are equal, therefore left hand sides are equal. Hence proof. 26. Insert two numbers between 3 and it1 so that the resulting sequence is GP. We have to insert two numbers between 3 and it1 so that the resulting sequence is a GP. Let x and y be the two GMs between 3 and it1. Then 3x, y, it1 are in GP. IT1 is 4 term, 3 is first term. Using standard formula, we get IT1 equal to first term is 3 times of R to the power 4 minus 1. Here R is common ratio. We get R equal to 3. Therefore, x equal to 3 into 3, that is 9. Y equal to 9 into 3, that is 27. 27. Find the value of n so that this expression may be the geometric mean between a and b. We have this expression equal to square root of ab. Squaring on both sides and cross multiply, we get this. Again, expanding on left hand side, this for right hand side, we get this. Equating like terms, we get this, and factorize, we get this, which gives power twice n plus 1 equal to 0. Solving n equal to minus half. Question 20i. The sum of two numbers is 6 times their geometric mean, so that numbers are in the ratio this is to this. Let x and y be the two numbers. Then x plus y, their sum, is equal to 6 times their geometric mean, that is root over xy. And simplify, we get this. Applying componendo and dividendo, we get this. And completing perfect square on numerator as well as in denominator, we get this. Squaring, taking out squaring, we get this. And again applying componendo dividendo on both sides, we get this. Simplify this by this, which gives this. Therefore, x is to y is equal to this is to this. Hence proof. 29. If capital A and capital G be AM and GM respectively between two positive numbers, prove that the numbers are a plus minus root over a plus b z times of a minus z. Let small a and small b be the two positive numbers. Then capital A equal to small a plus small b by 2 and capital Z equal to square root of product AB. Therefore, a plus b is twice a, which is equation 1. Squaring on both sides, we get a product AB equal to z square. Now a minus b whole square can be written as this. Put their respective values, that is a plus b equal to twice a and product AB equal to z square, and completing this, we get this. Therefore, a minus b is equal to 2 times of square root of a square minus z square, which is equation 2. Adding equation 1 and 2, we get twice a, cancelling plus b and minus b. In the right side, we get 2 times of a plus root over a square plus z square. Dividing 2, we get a equal to a plus root over a square plus z square. Equation 1 minus equation 2 gives b equal to this. 30. The number of bacteria in a certain culture doubles every hour. If there were 30 bacteria present in the culture originally, how many bacteria will be present at the end of second hour, fourth hour, and nth hour? The number of bacteria in a certain culture doubles every hour. If there were 30 bacteria present in the culture originally, how many bacteria will be present at the end of second hour, fourth hour, and nth hour? It is given that the number of bacteria double every hour. Therefore, the number of bacteria after every hour will form a GP. Here A is 30, R is 2. Therefore, A3 is equal to AR square. A is 30, R is 2, we get 120. The number of bacteria at the end of second hour would be 120. Also, A5 is given by AR power 4, and put their respective values, we get 4 IT. Therefore, the number of bacteria at the end of 4 hour will be 400 IT. A of n plus 1 is AR to the power n. Giving their respective values, we get 30 into 2 power n. Thus, the number of bacteria at the end of n hour will be 30 into 2 power n. Question number 31. What will rupees 500 amounts to in 10 years after its deposit in a bank which pays annual interest rate of 10% compounded annually? What will rupees 500 amounts to in 10 years after its deposit in a bank which pays annual interest rate of 10% compounded annually? The amount deposited in the bank is rupees 500. At the end of first year, amount will be rupees 500 times so 1 plus 1 by 10. That is rupees 500 times so 1.1. At the end of second year, amount rupees 500 times so 1.1 into 1.1. That is rupees 500 times so 1.1 whole square. At the end of third year, amount will be rupees 500 times so 1.1 power cube and so on. Therefore, amount at the end of 10 years the rupees 500 times so 1.1 to 32. If AM and GM of roots of a quadratic equation are 8 and 5 respectively, then obtain the quadratic equation. Let A and B be the two roots. Then AM equal to A plus B by 2 and GM equal to square root of product AB, which gives A plus B equal to 16 as AM is given as 8 and the product AB is equal to 25 as GM is given as 5, whose square is 25. Therefore, the quadratic equation is x square minus sum of a plus b times of x plus product ab equal to 0. Put their respective values, we get this, which is the required quadratic equation. Thank you for watching video.